Section 1.6 is translating problems into equations. And here you're given a word problem and you just have to write it as an equation, but you don't need to solve it. It's just trying to teach you how to set things up. So I'm going to work a series of examples so you can start seeing the pattern and how these things work. So in these problems, you're given two sentences. You're going to take one of the sentences and define the variables, and you're going to take the other sentence and use that to write the equation. So when I look at this, I'm going to use the first sentence to define the variables. It says Marta has twice as much money as Heidi. Usually you want to take the variable of the two, the one that's in the smaller amount, the smaller quantity. So if Marta has twice as much money as Heidi, Heidi has less money. So I'm going to use Heidi as the letter of my variable. So I'm just going to say Heidi's money, and I'm going to call that H because that's the one in the smaller amount. And then Marta's money, you have to define Marta's money in terms of H because you can only have one variable in these equations. So it says Marta has twice as much money as Heidi. Well, if Heidi has H amount, Marta has 2H. This is how you define your variables. So you have to show this part. Now, I've already used the first sentence to do this. So I'm done with sentence number 1. Sentence number 2, I'm going to use to write the equation. It says together they have $36. That means let me go down here. Heidi's money plus Marta's money, H plus 2H equals a total of $36. And that's the equation. That's really the simplest type, when they give you a relationship between the variables and then they just give you the total, what they add up to. That's probably the most basic kind. Example 2. These examples come out of the book, so they're all in there either as examples at the beginning of the section or as actual problems. Let's see, let me leave that down. Let me take this in. Oops, well that didn't work too well. All right, that's good enough. So example 2 has, it says a wooden rod 60 inches long is sawed into 2 pieces. One piece is 4 inches longer than the other. So the first sentence gives you a total, just like in the first problem. It had, together they have $36. If there's a sentence that gives you the total of both variables put together, then that's the sentence, that sentence you have to use to write your equation. So sentence 1 gives me the total of 60 inches. I'm going to use that one to write the equation. So the second one is going to be used to define the variables. One piece is 4 inches longer than the other. So all I know is I have 2 pieces. So piece 1 and piece 2, and one is 4 inches longer than the other. So I'll just call one of them P, and the other one, I'll say P plus 4. Now you could say P and P minus 4, it doesn't matter because they're just 4 inches apart from each other. So I've defined my variables, now I need to put them together to make the equation. That's when I use the first sentence. A wooden rod 60 inches long. Well, the 2 of these pieces have to add to 60. So piece 1 plus piece 2 equals 60. Don't put inches or units in your equation. And so let me just highlight, there's sentence 1, There's equation 1, equation 2. All right, example 3. Let's do this one. So you may start seeing the pattern. You may see it already, how this works. So State College has 620 students. There are 20 more women than men. So my variables are the number of women and the number of men. And it gives me the total of them combined. So I already know that sentence 1 has to be used to define the equation, or to write the equation. This sentence 2 is going to be used to define my variables. There's 20 more women than men. Well, there's fewer men than women, so I'm going to use M as my variable. So the number of men and the number of women, those are my two variables. Well, there's 20 more, so I said men, that's the smaller one, so that's M. I have to define women in terms of M. I don't want to use a W because then I have two variables. I have to have only M in my equation. So 20 plus M, because there's 20 more women than men, this gives me the number of women. So only M should be the variable. Now, sentence 1 will write the equation. We'll make the equation. So there's 620 total. So men plus women equals 620. There's my equation. All right. Example 4. So we've got, let's see. Now we have Brenda driving 3 times as far as Jan, and Brenda drove 24 miles more than Jan. So the two variables are how far Jan drove and how far Brenda drove. So we'll say Jan's distance, Brenda's distance, and now here you don't have a sentence that gives you a total. I don't have anything telling me what their combined distances equal. All I have are 2 different ways to relate these variables. In one case it says Brenda drove 3 times as far as Jan. In the other sentence it says Brenda drove 24 miles more than Jan. So it doesn't matter which of these 2 you use to define your variables and which you use to write the sentence. So I'm going to just pick the first sentence to define the variables. Brenda drove 3 times as far as Jan, so she drove farther. That means I'm going to use a J for my variable. So Jan's distance is J. Now Brenda drove 3 times as far as Jan. That will be 3J, 3 times J. Variables are defined. Now the second sentence is going to help me write my equation. Brenda drove 24 miles more than Jan. You could rephrase this to say Brenda's distance is 24 miles more than Jan. So I'm just going to translate that. Brenda's distance is, Brenda's distance, 3J, Brenda's distance is equals 24 miles more than Jan. 24 more than, that's plus. Well, Jan's distance is J. and you get this equation. So just to show you that it doesn't matter which sentence you use to define your variables, I'm going to do the same problem. So let's just say way number 1. Here, let me do the same problem a second way. Way number 2. And we should end up with the same exact equation. So if I take Jan's distance, Brenda's distance, and this time I'm going to use the second sentence to define the variables. So Jan still drove the smaller distance, so she's still going to be J. Brenda drove 24 miles more than J, so Brenda's distance is 24 plus J. So see, it looks a little different here. Now in this case, I'm going to use the first sentence to write my equation. Brenda drove 3 times as far as Jan. That means Brenda's distance is 3 times Jan's. So Brenda's distance is, I'm just rephrasing it so I can find the is. I need an is to write my equal sign. Is 3 times Jan's. 3 times, well, Jan's is J, 3J. Now if you look at these two, they're exactly the same. It's just that one's on the 3J's on the left here, the 3J's on the right here, but these are the exact same equation.